Hello. In this video, we will talk about apparent volume of distribution. We will start with some basic information and slowly dive deeper and deeper into the concept of apparent volume of distribution. Let's get started. First, let's see various body compartments. This is a simplified diagram of body showing all the compartments. This is plasma in blood vessels. It is considered central compartment. This is interstitium. And these are cells. In healthy adult person of 70 kg weight, plasma volume is about 4 liters, interstitial volume is about 10 liters, and intracellular volume is about 28 liters. Thus total volume is about 42 liters. Coming to the distribution of the drug. When we give a drug, it spreads to various body areas. Different drugs spreads to different extent. If a drug largely stays in vascular compartment, we can say it's distributed in 4 liters of space. In this case, its concentration in plasma would be high. If it also spreads into interstitial space, we can say it has spread in total of 14 liters of space, 4 liters in plasma and 10 liters in interstitium. And obviously, its concentration in plasma would fall. If it also enters cells, we can say it's distributed in 42 liters space, and the concentration would be even lower. To know how far the drug is spreading, ideal would be to take samples from all the body tissues and measure the concentration of drug in each area. But practically that's not possible. You cannot take samples from all the body organs just like that. Rather, what is convenient is to take sample from plasma. We have already seen that plasma concentration of drug falls as it spreads more and more. So we can know how far the drug is spreading based on how much it is getting diluted in the plasma. For this, we need a simple formula from chemistry. Concentration is equal to weight of solute divided by volume of solution. For our purpose, it will be concentration of drug in plasma is equal to total amount of drug in body divided by volume of space where the drug has spread, or in fancy words, volume of distribution. And it will be rearranged like this. So volume of distribution is equal to total amount of drug in body divided by plasma concentration of the drug. We can know total amount of drug in body from the dose that we have given. The plasma concentration shows how much the drug is getting diluted. So the volume that we get from these numbers is volume of space where the drug is spreading. For example, if the spread is less, the plasma would stay relatively concentrated. When you put that high value of the concentration as this denominator here, you get small value for volume. This suggests that the spread is less. And if the spread is more, the concentration decreases, and with smaller value of concentration, you get larger volume. This indicates that the drug has spread more. Thus, this equation is very handy to know how far the drug is spreading. However, there are some limitations of using this equation. See, the drug is spreading throughout the body, but we are measuring its concentration only in plasma. It's quite possible that distribution of drug is uneven in different body areas. For example, here the drug is highly concentrated in this area has low concentration, and in this area, the drug has not spread at all. But we are not measuring concentration in all these areas. We are measuring it in plasma only. So the results that we get are based on collective impact on plasma concentration. It's like this equation is watching the body from here. It is seeing the entire body, but only through plasma, which behaves like a goggle. Just like a black goggle makes everything look blackish, this plasma makes everything in body look like plasma. In other words, this equation assumes that everything in body is like plasma, including the concentration of drug. So when we calculate volume using this equation, it's the volume of this apparent plasma. It does not give the volume of actual space where the drug has spread. That's the reason why it is called apparent volume of distribution. So this is the limitation. The volume that we are measuring is an apparent volume, not a true volume. in spite of this limitation, it is a useful parameter. It gives a rough idea about how deep the drug is spreading in the body. Apparent volume of distribution of less than 5 liters suggests that the drug is mostly staying in the blood. Obviously, because that's an approximate volume of blood. Example of such drug is heparin. If the volume of distribution is about 15 liters, it suggests that the drug is spreading into the interstitium, but not spreading into the cells. For example, gentamicin. And volume of distribution up to 42 liters generally means that the drug is entering the cells also. For example, phenytoin. Now comes the interesting part. Sometimes you get volume of distribution far more than total body volume. For example, chloroquine. Its volume of distribution is about 15,000 liters. Yes, I'm saying 15,000. How is it even possible? Let me explain. Chloroquine has high affinity for some cellular components. So when you give chloroquine, it gets concentrated in cells of liver, spleen, kidney, etc. Because of this, plasma concentration would be very low. And when you put this very low value in the equation, you get the volume that is very large. Thus, the real reason why the drug is getting diluted is its sequestration in deeper tissues, not the actual large volume of body space. But from viewpoint of equation, the drug is evenly distributed with same concentration as plasma. So it gives volume that is larger than total body volume. This is perfect example showing why it is an apparent volume, not a true volume. So this was all about apparent volume of distribution. As a summary, I will briefly explain definition of apparent volume of distribution. It is a volume that is apparently there to contain all the drug in body at the same concentration as in plasma. And the equation as we have seen is apparent volume of distribution is equal to total amount of drug in body divided by concentration of drug in plasma. In definition, yes, it's an apparent volume, not a true volume of space where the drug is spreading. We are using total amount of drug for calculation. So this part, contain all the drug in body, is also checked. Finally, at the same concentration as in the plasma. This is because we are measuring this volume with plasma as our reference point. So that was the definition. One last thing. To keep the discussion simple, I have mentioned all the volumes for 70 kg adult person. To make the values applicable to people with all weights, we can find the volume per unit weight. For that, we would need to divide volume by body weight. In that case, the unit will be liters per kilogram. But that is just a technicality. The concept that you need to understand is what we have seen in detail. I hope you now understand the apparent volume of distribution. That's it for this video. If you found this video helpful, please share it with your friends and colleagues too. And don't forget to subscribe Nonstop Neuron, where learning medical concepts is as easy as watching cartoons. Thanks for watching. See you in next video.